Okay, this is the chapter on water and air. This is a sort of chapter in which I collected all the information that we need with respect to water and air. So we've already done most of this. We've already done this. We said for water, there is a chemical test and there is a physical test. And remember that the chemical test is, one of the chemical tests actually is add anhydrous copper sulfate. And we said the word anhydrous means it doesn't have any water in its crystal. Now, if you add water to that, then it becomes hydrated copper sulfate, and hydrated copper sulfate are crystals that form taking some water with it. So when we add water to anhydrous copper sulfate, it turns from white to blue because it changes from anhydrous to hydrated copper sulfate. Now, the physical test, we said that is the test for pure water. So if we test with copper sulfate, it just tells me that there is some water in there. But to test for pure water, we said heat to boiling. It should boil at 100 degrees centigrade. So this was one sample question. Separate samples of anhydrous copper sulfate and hydrated copper sulfate are heated. Which row shows the correct color changes? So let's remember again, the anhydrous one is originally what color? It's originally white. So the anhydrous will change. He's saying, what did he do to it? He's saying he took the anhydrous and hydrated and heated it. Now, if you heat the anhydrous, what is going to happen to it? No change will happen to it because it's originally white. So there is no water in it to remove. So it just remains the same. But the hydrated is originally what? The hydrated is originally blue. Now, if you heat it, you remove the water. So that means that it will turn from blue to white. So that is the opposite of the reaction that we said. If we heat the hydrated one, it becomes anhydrous. So it turns from blue to white. Okay, water is added to hydrated copper sulfate. Which color change takes place? Again, we said the hydrated is what color? The hydrated is originally blue. Now, it originally has water already. So the hydrated already has water. So if you add water to it, there is no change in it. Okay. The next thing we need to talk about is purification of water for drinking. You have to remember that water has to go through two processes to be purified for drinking. The first process is filtration. So the water is basically allowed to settle through layers of sand and gravel and pebbles and things like that. While it is going through all of this, we are removing the suspended solid particles. That means we're removing anything that is insoluble in the water. So this is to remove suspended solid particles. It also decreases the amount of bacteria, but it does not kill all the bacteria. It does not remove all the bacteria. It just decreases the amount of bacteria. So that is the function of the filtration part. Now, after that, the water that comes out, we need to kill all the harmful bacteria in it. So it goes through a process of chlorination. Remember that the use of chlorine is to kill harmful bacteria in drinking water. Okay. Typical sample question. Water must be purified before it's suitable for use. Which processes are used to remove solid impurities and to kill bacteria? Remember, to remove the solid impurities, then you did what? Filtration. That's the one that removes solid impurities. Now, which one kills the bacteria? The chlorination process. Then we're going to talk about air, and you're going to know that air is mainly nitrogen. So nitrogen makes up 78% of air. Sometimes we say 79%, but in this we're going to say 78%. The oxygen is 21%, so we're left with just 1% left. Most of it is argon, so argon is 0.9%. Carbon dioxide is 0.03, sometimes it's written as 0.04% since it has gone up. Water vapor could be variable. So this is the main composition of clean air. Remember, air does not contain hydrogen gas. Remember again, which noble gas is present? Most of it is argon. what is the gas that has the highest percentage in air? Nitrogen. If I say name two elements present in air, what are the two elements present in air? Nitrogen, oxygen, argon actually. So we have three elements present in air. If we say name two compounds present in air, then carbon dioxide and water vapor. Okay, how do we obtain nitrogen or oxygen from air? Remember that air is mostly nitrogen, so this is how we obtain nitrogen for a process like the Haber process to make ammonia. So to obtain nitrogen or oxygen from air, we do fractional distillation of liquid air. That is the process, fractional distillation of liquid air. We need to go through what? First of all, the air is filtered and then it is cooled under pressure and that forms a liquid. Now, we said air is a mixture of gases, so when it becomes a liquid, it becomes a mixture of liquids. And to separate a mixture of liquids, we do fractional distillation. Okay? Okay, if we get oxygen, what are the uses of oxygen? Please don't say respiration. When we say uses of oxygen, we mean on a large scale in the manufacture of something or in the making of something, not respiration. Don't say it's used in respiration. So where do we use oxygen? We use it in oxygen tents or oxygen cylinders in hospitals and for divers. So we use it oxygen tents in hospitals, oxygen cylinders for divers. Also, we combine it with a gas called acetylene to form a flame that has a very high temperature. And this flame is used in welding metals. So one of the uses of oxygen is in welding metals. Okay? So which gas is not present in clean air? Which of these is not present in clean air? Remember, clean air will not have carbon monoxide. We get carbon monoxide only when we burn something in incomplete combustion with very little oxygen, then you get carbon monoxide. But it is not an original gas. Remember that carbon dioxide causes pollution, but there is some carbon dioxide in the clean air. So carbon dioxide is present in clean air, but carbon monoxide is not. Okay, another sample question. It says the pie chart shows the composition of air. What are the gases in 1, 2, and 3 of the pie chart? Remember, a pie chart shows the relative amounts of each of them. So number 1 would be which one? Number 1 is the gas that makes up most of air. What is the gas that makes up most of air? Nitrogen. So my answer is A or B. What about 2? 2 would be oxygen, because oxygen makes up 21%. And then we have other gases. Okay? Okay. Now, this is a typical experiment that he usually talks about. How do I determine the percentage of oxygen in air? Now, I determine it by reaction with copper. So we get copper wire, and we know that copper is originally what color? Reddish brown or red or brown. So that is the copper wire. And then we heat the copper wire in air. So these two syringes are originally filled, let us say, with a total of 100 centimeter cubed of air. And then the copper is heated and the syringes are pushed one and then the other to pass the air over the copper. When the air passes over the copper takes up all the oxygen and becomes copper oxide. When there is no, and the amount of air in the syringe will what? It will decrease. So it will keep decreasing until all the oxygen has been used up. So when there is no more change in the volume of air in the syringes, then we allow everything to cool and we determine the final volume, and the difference is the volume of oxygen that has been taken. Okay? How do we prepare oxygen in the lab? We have talked about this hydrogen peroxide. When you add a catalyst to it, it breaks up to give oxygen gas. So the hydrogen peroxide is introduced to a flask containing manganese dioxide, and the gas given off can either be collected as shown over water, and we know that we can collect it over water because oxygen is only very slightly soluble in water, or we can just attach a gas syringe and collect it in the gas syringe. Okay, so a typical question, an experiment to find the percentage of oxygen in 150 centimeter cubed of polluted air is shown. The apparatus is left for 1 week. So this is another method of determining percentage of oxygen. When he puts iron, you know that iron will rust because it is damp, so it has water, it's in air, so it has oxygen, so that iron in the iron wool will rust. Now when it rusts, it uses up the oxygen in the air, so the water moves up to displace the oxygen that was used up. Now what is the percentage of oxygen to the nearest whole number? How do we know that? He says the volume of the gas became 122. So at the beginning it was 150. Now when we used up all the oxygen, it became 122. So I can determine the difference will be oxygen, and the percentage will be the difference over 150 times 100. The difference over the original volume, 150 times 100. If you do that, it will come up to be 19%. Okay, air pollution. These are the pollutants that you're supposed to know about, how they are formed and their effect. The word pollutant means a substance that is not originally in air. So a substance that pollutes is called a pollutant. So a pollutant is a substance that is not originally present in air. Now, which pollutants are we talking about? First of all, we've talked before about carbon monoxide, and we said, how is carbon monoxide formed? It is formed by incomplete combustion of fuel. Now, what is the problem, or what is the effect of carbon monoxide? In that it is poisonous or toxic. Sulfur dioxide we talked about when we were talking about, for example, in the blast furnace. Now, the combustion of fossil fuel releases sulfur dioxide. This is because usually fossil fuels have a small amount of sulfur impurities. So when you burn coal or petroleum or any fossil fuel, usually it has sulfur impurities, so that releases sulfur dioxide into the air. And you should realize that sulfur dioxide causes something called acid rain. That is because it goes up into the air, reacts with the oxygen in the air, dissolves in the water vapor in the air and forms acid, and that falls as acid rain. Now, acid rain has many effects. Kills plants, marine animals, destroys buildings, and we'll be talking about that in detail. This is just an overview of the pollutants we're going to talk about. Now, oxides of nitrogen. Oxides of nitrogen come out of the car exhaust, and we will talk about that in a minute. And the oxides of nitrogen are the other type of gas that cause acid rain. So remember that there are two types of gases that cause acid rain: sulfur dioxide and oxides of nitrogen. Oxides of nitrogen, that means nitrogen monoxide, nitrogen dioxide, and so on. We have different types of nitrogen oxides. Now, lead compounds are something that come out of car exhaust, and that is because the petrol or the gasoline that is put into cars as fuel usually has lead compounds added to it or lead impurities, and when this comes out of car exhaust, this causes brain damage. So you need to know this. Okay, now let's talk about this in detail. First of all, sulfur. We said if we're burning coal or petroleum, fossil fuels, it has sulfur impurities. When we burn coal, the sulfur burns in air with a blue flame to form sulfur dioxide. So the sulfur dioxide formed can either dissolve in water, and when it dissolves in water, it forms what we call sulfurous acid. Can you see this? H2SO3. Or the sulfur dioxide could be oxidized to sulfur trioxide and then dissolve in water to form sulfuric acid. So remember, sulfur dioxide in water forms sulfurous acid, H2SO3. Sulfur trioxide in water will form sulfuric acid, H2SO4. And all of this falls in, dissolves in rainwater and dissolves as acid rain. Oxides of nitrogen, how do we obtain them? The oxides of nitrogen are formed in the car engine. This happens when we start the car. So starting the car, which is called ignition, when you turn your key to start the car, this is ignition. This causes an electric spark in the car engine. Now, this electric spark causes the nitrogen oxygen gas in the air around the engine to react and form oxides of nitrogen. Remember that the air around us already has a lot of nitrogen and oxygen. Now, they're standing next to each other, they're not doing anything. They're not going to react unless if there is some sort of something that will start the reaction. So what starts the reaction could be an electric spark in the air, or if there is lightning, when lightning happens, that is a sort of electric spark that causes the nitrogen and oxygen in the air around the engine to react. It forms oxides of nitrogen, and that is released from the car exhaust. Another way that we can have oxides of nitrogen are factories and fires. The factories are very hot, or the fires release a lot of heat, and that heat also allows the nitrogen and oxygen in the air to react to form oxides of nitrogen. Okay, so sources of oxide of nitrogen either in the car engine due to the electric spark, or from something that is releasing high temperature like factories or fires. They release high temperature, and all of this causes the nitrogen and oxygen in the air to react to form oxides of nitrogen. Okay, now we don't want harmful gases to come out of the car exhaust. So now most of the new cars have what we call catalytic converters placed on the exhaust of the cars. You know that the car exhaust is something at the back of the car that releases the gases from the car. Okay, the catalytic converters are placed on the car exhaust, and this is to prevent release of harmful gases. Now, how does it work? The catalytic converters contain catalysts, and these catalysts cause the harmful gases, which are carbon monoxide and nitrogen monoxide, for example, to react together. When they react together, the gases that are formed are safer gases. So if we react carbon monoxide and oxides of nitrogen, this forms carbon dioxide, which is already present in the air, so there is nothing we can do, and nitrogen gas, which is harmful and also present in the air. So these are regarded as safer gases. Also, if there are any hydrocarbons, these are broken down so that they are released out of the car exhaust. Now, there is something called flue gas desulphurization. We said that gases coming out of factories or usually contain oxides of sulfur, because the factories burn fossil fuels. The fossil fuels have sulfur impurities, so sulfur dioxide comes out usually from the chimneys in factories. We don't want this, because when the sulfur dioxide comes out, it causes acid rain. So we need to remove it from the chimneys before it comes out into the air. So the process that we call flue gas, the word flue gas means waste gases coming out. So flue gas desulphurization means removing the sulfur dioxide from the waste gases coming out of factories. So we're trying to remove sulfur dioxide because this is acidic and it forms acid rain. We remove it from the waste gases that come out of the chimneys. Now, since it is acidic, how do we remove it? We remove it by putting something that is a base. So at the top of the chimneys, there is limestone or slaked lime. Slaked lime is calcium hydroxide and limestone is calcium carbonate. Note that. Limestone is calcium carbonate. Slaked lime is calcium hydroxide. So these are basic. They react with the acidic gases so that the gases that come out are neutralized. Okay? So that is an important process to remove the sulfur dioxide from the waste gases in factories. Okay, question. Which row showing an air pollutant and its major source is not correct? So we're going to choose which one is not correct. Okay, let's take a look at A. A says carbon monoxide comes out from complete combustion. Well, that's my answer. Carbon monoxide comes out from what? Incomplete combustion. So A is wrong. Let's take a look at the others. B, lead compounds from leaded petrol. Well, that's right. Lead compounds come due to leaded petrol. Oxides of nitrogen are from car engines. That is correct. Sulfur dioxide are from fossil fuels that contain sulfur. That is correct. So the only one that's not correct is that first one. Okay, acid rain. Let's talk about acid rain in detail. First of all, we said which gases cause acid rain. We said acid rain is caused by sulfur dioxide gas coming from factories or nitrogen dioxide gas from car exhausts. Okay, so the two gases are sulfur dioxide gas and nitrogen dioxide gas. Where is sulfur dioxide gas formed? In factories. And where is nitrogen dioxide gas released from? From car exhausts. Okay, now these go up and become oxidized, dissolve in rainwater, become acids. So the sulfur dioxide will form at the end, once it has been oxidized to sulfur trioxide and then dissolve in rainwater, it forms sulfuric acid. The oxides of nitrogen would form nitric acid. Now these acids dissolve in the water, in the rainwater, and fall with the rainwater, so we call that acid rain because this is acidic. Now the acid rain is a very serious problem because it has many effects. So what did we talk about in acid rain? We said one of the effects of acid rain is that it dissolves limestone in buildings and statues, causing them to crumble. So that is one main effect that is happening to many important buildings around the world. Okay, when it falls in rivers, well, it makes the water in the rivers and the lakes acidic. So this kills all the marine animals living in the river, and we find that the fish starts to float on the surface of the water because it is killed with the acid rain. Okay, when it falls on trees, it destroys the leaves, it destroys the roots, so it kills the plants, and it could end up destroying whole forests due to the acid rain. Okay, what is the effect on the health? So sometimes he says, what is the effect on the environment? What is the effect on the health? Well, when we inhale air that contains acid, so that is acidic, it will damage the respiratory system. So, question: a steel works and a chemical works are built near to a city. Remember, works here means factory. A steel factory and a chemical factory are built near to a city. The limestone buildings in the city begin to crumble. Which gas is most likely to cause this damage? Why are the buildings crumbling? Due to sulfur dioxide causing acid rain. Okay. Sulfur dioxide gas is a common pollutant formed when fossil fuels burn in air. Sulfur dioxide can be detected by using an acidic solution of potassium dichromate. The dichromate solution changes color from orange to green when a certain amount of sulfur dioxide has reacted with it. Plan an experiment to investigate which of 3 different samples of coal produces the most sulfur dioxide. So basically, he's going to give us 3 samples of coal, and we want to know which one produces more sulfur dioxide. Well, how can I test for the sulfur dioxide? He said that sulfur dioxide changes potassium dichromate from orange to green. So how are we going to explain this kind of experiment? Well, we're going to get the coal, put it in an evaporating dish, and basically what we're going to do is we're going to burn each of this in air and collect the gas that comes out, pass it through potassium dichromate. Now, the one that gives out more sulfur dioxide will be the one that does what? If it gives off more sulfur dioxide, then the color of the potassium dichromate will change very quickly. If the sulfur dioxide gas coming out is not very much, then the potassium dichromate will take a long time to change color. Agreed? Okay, how do we explain this? We said, first of all, if we're comparing between 3 different samples of coal, so the first thing that we need to do is weigh each of them, because we need to compare and weigh the same mass of others. So we're going to choose one and then say repeat with the others. So weigh 10 grams of the first sample of coal using balance. Do not forget to mention apparatus. Put into an evaporating dish. Cover with an inverted funnel connected to a delivery tube. Put 20 centimeters, be specific that we're going to use a specific amount because we're going to repeat it with the others. Put 20 centimeter cubed of potassium dichromate into a test tube using measuring cylinder. Put the delivery tube into the test tube. Burn the coal. measure what? Remember that we need to measure something in the experiment. So here we're measuring the time taken for the orange color to change to green. Now we're going to repeat using what? What is going to be the same when we repeat it? The same mass of the coal, so 10 grams of the other samples of coal, the same volume of fresh potassium dichromate, so we're not going to use the same solution every time. And the one that causes what? The one that causes the faster change in color is the one that is giving out more sulfur dioxide. Okay? Okay, let's talk about greenhouse gases. Now, we should know that there are two gases which cause greenhouse effect, carbon dioxide and methane. Now, we have increasing amount of carbon dioxide in the air. Why is the carbon dioxide increasing in the air? You should realize that we're burning a lot of fossil fuel, and that releases carbon dioxide, and we're cutting down forests. Deforestation, we're cutting down forests. How does that affect the amount of carbon dioxide in the air? Remember that photosynthesis in plants is the only process that takes carbon dioxide from the air. All other processes give out carbon dioxide. Respiration gives out, burning gives out, and so on. But the only thing that can take carbon dioxide from the air are plants doing photosynthesis. So when we cut down forests, then there are less plants taking carbon dioxide from the air, and that means that the amount of carbon dioxide in the air will continue to rise. Now, when the carbon dioxide rises, this causes what? We call it greenhouse effect, or we call it global warming, because the carbon dioxide in the air traps the heat, so the temperature of the earth rises. Now, this is bad because if the temperature rises at some point, it will rise above zero in the North Poles, and the ice in the North Pole starts to melt, leading to flooding. Okay? Now, the other greenhouse gas is methane, and it does the same thing. So presence of methane or carbon dioxide gas, they trap the heat around the earth, causing a rise in temperature, causing melting of the ice in the North Poles, which leads to flooding. Okay, where is methane produced from? It is produced by decomposition of vegetation. That means if we have dead plants and the bacteria are breaking them up, this releases methane. They also come out as waste gases from digestion in animals. So the two sources of methane, decomposition of vegetation, waste gases from digestion in animals. Question: which row is correct for both carbon dioxide and methane? Okay. Do they both cause climate change? Yes, both of them cause climate change. Are they both produced by burning fuel? No. Methane is not produced by burning fuel. Methane is produced from decomposition of vegetation or digestive system in animals. Okay, are they produced, both of them, produced by living organisms? Well, yes, they can be produced by living organisms because carbon dioxide is given out during respiration of living organisms, and methane is formed in the digestive system of animals or from decomposition of vegetation. Which pollutant gas is produced by decomposition of vegetation? We said decomposition of vegetation will vegetation will produce what? It will produce methane. Okay, methane and carbon dioxide are both greenhouse gases. Which row identifies a source of methane and a source of carbon dioxide? What was the source of methane from these? Actually, we said methane can be obtained from both decomposition of vegetation and digestion in animals. So A and B are both correct. Now, source of carbon dioxide. Where does the carbon dioxide come from? Remember, will it be formed from hydrogen car exhausts? No. Hydrogen, when it burns, it releases only water. It doesn't release carbon dioxide. But it will be formed when you burn things like diesel, which is a fossil fuel. Okay, that's the end of the short chapter that we're doing. Study everything and do the questions. And